This podcast is brought to you by Deepbridge Capital LLP. Deepbridge is authorised and regulated by the Financial Conduct Authority. Please note that investments discussed are both illiquid and high risk and won't be suitable for all investors and should be considered as part of a diversified portfolio. The content of this podcast should not be construed as financial or taxation advice. We recommend investors seek appropriate professional financial advice. Any views expressed may no longer be current and may have already been acted upon. Today, I'm delighted to be joined by Joe Ward, founder and CEO of SmallSpark Space Systems. So, Joe, welcome.
Thank you for having me.
Great to see you. So, as always, we try and keep these conversations fairly informal, so just people can get a flavour of kind of who you are, who SmallSpark are, etc. So, I guess, can you just start off by start off at the beginning and kind of a bit about your background prior to SmallSpark and kind of where SmallSpark came from?
So my background's in physics. I have a degree in physics from Cardiff University. And then SmallSpark actually span out of my research I was doing for my postgraduate degree. So I was doing a degree in astrophysics with propulsion system design, which kind of showed that I had two passions. And around 2/3 of the way through that degree, I spoke with my supervisors and we very much realized I couldn't run SmallSpark and do my degree. And so I was almost given this ultimatum of I had to pick, essentially, what do I do? Do I pursue SmallSpark full time or do I put my degree on? I mean, I tell myself I put it on pause, but we'll see whether I actually end up returning to it.
Time will tell.
It's been on pause for 3.5 years now. So I chose to then just pursue SmallSpark. So I did essentially a lot of the preliminary work and concept stuff while I was studying for my degree, essentially planning for my research project. I never actually got to the research project stage. I pretty much did the entire degree, paused at the research, and decided to essentially do the research myself. But funny enough, I actually probably work with my supervisors and would-be supervisors more now because I've maintained that contact with academia than I would have if I'd actually done the research, which is always quite interesting. It's quite strange engaging with them on more of like a commercial agreement basis.
I was going to say, kind of on as peers rather than as kind of students.
I'm still getting used to it. I'm still getting used to it. It still feels very strange because we do a lot of work with academia. We have a lot of very strong engagements with universities like Southampton, Swansea, Cardiff. And it's still very strange engaging with someone who I know is a supervisor for other PhDs, things like that. And they see us as the equal. They always see me as an equal, but I always still have to get used to realizing, we are actually on the same level, technically. Academically, they're light years ahead of me.
It's always that strange moment in life when you realize you're a grown-up yourself, isn't it? But,
I'm kind of hitting that point now. I'm going, oh my word, I am a proper grown-up now. It's very strange, but it's really cool when actually working with graduate students because, for the longest time, I was the youngest person in the company, which I think is probably a good thing, to be honest. All the engineers are far more experienced than I am. But no, we're starting to now get graduates in who are almost the age that I was when I started the company. It's really exciting to sort of see the passion they have for what we're doing as well. So I can sort of see the fire that I have, in their eyes. It's fantastic to see. But we get all of that from working with academia as well.
Yeah, brilliant.
Quite a bit of a tangent there. Sorry.
No, absolutely. That's what this conversation's all about. So I guess how's the company evolved then since you founded it, and kind of I guess how's the team grown? You talked about the engineers, etc. Kind of what does SmallSpark look like today? I guess.
So when we started, as was probably wise, I was told by all of my supervisors and tutors to stop it and just. You're being an idiot. And they were probably right, to be honest. It was a bit of an insane thing to try and do, especially as a 22-year-old student, because it was an insane prospect for what we said we were trying to do. I told them we were going to build rocket engines, which is kind of really cool idea of using really simple designs, these kinds of things. And so initially I was just told, no, don't do it, please, just don't. We care about you, don't be silly. But I'm very bullheaded, so I just essentially told myself I can do both. I can do my degree and work on this. And it was only then I chose to pursue SmallSpark full time because I was seeing the actual traction. We were starting stuff and going, oh my word, this actually works. There's actually this really good idea that we thought of that's actually working now. And so about 6 months into founding the company is actually when the founding team finally came together. So there were 3 of us. So it was myself, Safe, who is one of our computational modeling engineers, and Anton, who was our CTO. And so Anton was by far the most experienced engineer who joined us. He has almost over 20 years in the industry, working everything from submersibles to robotics that work within nuclear reactors. So he's got everything that ties everything that I and my other co-founder were missing. Anton had it in droves. So that was us in sort of late 2018. There was 3 of us. We're now a team of 9 engineers now. We've just started going on a bit of a hiring spree after sort of being started to close this next round, where we've hired 3 new engineers this year already. They were interviewed the prior year. Don't worry, we didn't just bring them on within a few days of the year. But no. So we're growing our development team now. Because this is something we spoke to Adrian a lot about, and to Deepbridge in general. Is that right now our problem wasn't whether the tech works or whether the market was there. It was that we can see this opportunity. Our team was too small. So we've had for years planned the exact team we need, and we're now just starting to implement that. So we're a team of 9 now. We're aiming to be a team of 15 by the end of March. We're constantly interviewing candidates on a weekly basis now just to fill up all these critical roles.
As a company,
that's the rate we grow at.
You're looking at hardware and software, aren't you? So do you have kind of separate teams, or how does that work? And can you just tell us a bit about the kind of the products on both sides?
Yeah, so this is so the hardware and software thing is a really interesting thing to touch on. I think I need to give some more context to this. So we do hardware on these really cool rocket engines, which are designed to be safer, cheaper, and we think will allow more agile, responsive launch vehicles. But we also develop essentially what started out as a tool to help us design rocket engines better, because we were such a small team. We realized we haven't got the capacity to do this. We need to find a way to use AI to help us. We accidentally created this incredibly capable optimization software that we've just continued pushing forward. But you're right, so we have a hardware and a software team. But what's quite unique about the SmallSpark proposition is, for years we were told split the companies or drop one. Right. We think it took us almost 3 years to actually get investment funding. We basically ran off grant funding and out of pocket funding and working side jobs to fund the company for 3 years, because investors were normally worried that we were confused. And I was, for 3 years, very bad at conveying the message of why I wasn't confused. I was just very bad at conveying, and I looked confused. But what we're building is essentially a very solid base, what you need for being a responsive launch company. And it's not just having responsive hardware, it's having very specifically designed responsive software for your needs. So while internally we do have these 2 divisions, there's a lot of cross communication between these 2 divisions. They have their own missions, but those missions all support our core mission of lower cost access to space. So we use our AI software to just start speeding up certain design processes. So it's a lot of preliminary design work. It can take a lot of time. It can take weeks sometimes. And so we're building a tool that can cut that down to potentially days, and it can be done by 1 or 2 engineers instead. Just setting up essentially the problem, and it's how to just sort of define these problems to a tool, and it does all the grunt work up front. So it's 2 separate divisions that we're both growing aggressively, but we are very careful with how we develop our software to make sure it does integrate with what we're doing internally, as well as work well with what we're engaging with on commercial basis with our companies outside of SmallSpark.
Absolutely. And I guess if you've got hardware and software, is software a potentially shorter route to commercial markets? Is that yes,
fair? Yeah, no. I think this is kind of why I was always keen to really keep the software being pushed forward aggressively. We were always able to push it to be in line with what we were doing, but I wanted to push it a little bit further, to be honest, because our software is already being commercialized. And I think I'm incredibly proud that we've managed to be a company as small as we are now. So up until last week, we're a team of essentially 4.5 people, and we've managed to build rocket engines that are working and already begun commercializing what I would define as a revolutionary tool with very large defense contractors who are incredibly excited at its capabilities. What's so unique about this tool is that, as I mentioned, because it was designed to do such a difficult challenge of automating the design of difficult parts of rocket engines, we created a tool that we found didn't exist in the market, which was essentially an optimization tool that can tackle problems that don't already have solutions. So there are lots of optimization technologies and AI-based technologies for assisting engineering.
Right.
The issue is they're very quick and they're very, very capable tools. The problem is they are not built to tackle new problems. They are good at tackling problems that exist, like car spoilers and things like this, and gas turbines, stuff like that. They're very good at that. And more AI is also very good at that. But it was very much designed from the ground up to tackle problems with no solution or no known answers.
And your specific problems.
Exactly. And we found that if you can do that, there's actually an immense need within the market for that.
Yep.
Because all these R&D companies and these R&D arms of companies are all working on brand new problems. And so when we spoke to these defense companies, we were just talking to them about saying, you don't need to have these large data sets, because that's the problem they've had in the past,
Yeah.
is that they'll want to speed up their workflow, but the companies will go, well, we need 4,000 data points of similar problems to start working with. Whereas we don't do that. Instead, More AI creates its own data sets based on the problem. And this is what's so clever about it. It means it's not as quick to begin with as these other tools, but as it gets to learn your system, it catches up to be almost just as fast as these other tools. It just has that learning period, which is incredibly exciting. And it's a really cool area to be working on, because there's a ton of area of innovation within that.
And it's learning how you want it to learn as well, which is an important thing to make sure you're optimizing what you're doing.
The difference with More AI is it was very much designed from the beginning to remove human bias from engineering. When you're using data sets created by humans, you are, no matter how hard you try, going to be putting in
there's always a subconscious bias
into the problem. And if you want to avoid that, you have to go through workarounds to try and remove bias. With More AI, it's not a problem. You just set up the problems that you want, and you tell it you find the best solution you can. And it's been designed in such a way that it's constantly keeping track of how it's solving a problem to see if it can solve it in a better way. So it tries to track how it's solving, going, this is not working too great. I'm finding essentially false solutions. But in the back of its head, it's always looking for other solutions as well. As it was almost created by accident, which is the most exciting thing about it. We didn't set out to create a tool that was unique in the market.
But then it has a commercial relevance that actually you can take forward. Absolutely.
We found we were lacking the tool we needed. So we built it in the collaboration with Research England and University of Southampton, Department of Operational Research, who's one of the world leaders in optimization tools. And we accidentally created More AI. And it's amazing to see the response we're getting from it now, where we're starting to engage with actually the R&D arms of a lot of companies.
I was going to say, so in terms of the opportunities in the market and kind of the market that you're targeting, can you just tell us kind of just very briefly kind of what that market is, kind of what the gap you're filling is?
Is this in the optimization market, or in terms of all the markets we're going
across the board? What SmallSpark?
Yeah, absolutely. So I think the space market is the market I'm most passionate about, that we're going after. I say I'm Director of Propulsion Systems are my real passion. And so the market for space, especially within the UK, is that the UK is really seeking to become a globally dominant player in all of space. And we're very, very good in 95% of the space industry, but the thing we're lacking is actual access to space. Within the UK, you really can't access space yet. So what we are doing is that there's manufacturing satellites here, and we're shipping them off to the US or to India to launch. And that's lost revenue. And the government realized this a few years ago. And they realized it was essentially became a top priority to start getting spaceports in the UK online. And the market we're going for, we're really going for two types of markets. Very specifically, we're going for low mass payloads. So as technology matures, computers get lighter, we are going for satellites that generally are below 400 kilos. In general, the trend for satellites is going down, although there's a slight correction in the market where there are now launch vehicles on the market that are probably a bit too small. So some initial companies came on, and they're targeting the 1 to 200 kilo range. And they're capturing part of the market, but they're missing a lot of it. And we think we've come in at the right time, where we've almost seen the initial correction from people trying to get in very early. And we're seeing it's trending up and plateauing out now at this number of around 300 to 400 kilos. This is the market we're really going for, is satellites in that payload range. So very specifically within that market, we're trying to offer to customers very, very short lead times on launches. So typically, if you look at reports from leading consultancy groups, the lead time on a launch can be anywhere from 6 months to 18 months, depending on the provider you're using. Sometimes it can be even longer in unique cases. And the issue with that is that's fine for companies like Boeing or any large company worth billions. But if you're a small startup who has just maybe raised a £5 million round, and 4.5 of that is going to making this system be built and online. Every day your system is not in space generating revenue, you're losing money. So it's not every day that your launch is delayed, the company essentially is paying for that. And so when you start to include that in launch costs, suddenly launches are becoming phenomenally expensive for these companies. Because yes, a company can say we can launch you cheap, but if you're waiting 6 months, you're losing out on millions on revenue.
I was going to say, is the delay predominantly due to demand and supply, or kind of availability?
It's partially because of that. There's not enough vehicles, but also it's that vehicles just have problems. The thing is, rockets are complex. And so what we're trying to do is try and strip out all the complexity from these vehicles. So in our rocket engines, we are very open that our efficiency is maybe close to 90% of that, and you would see a lot of our competitors. We're not trying to position ourselves as the next SpaceX in terms of the most advanced equipment on the market. We're trying to go for a very different approach, very different philosophy of we're sacrificing a little bit on our performance, but we are making immense saving on cost and time to develop and time to do iterations in our designs, and time to
I guess,
manufacture.
well. Yep.
And one of our big things is on ease of transport of our system. So I think we will hopefully be the only provider of rockets that actually use non-explosive fuels, which seems almost contradictory that our fuels aren't explosive, but they're totally non-explosive, totally stable in almost all conditions you'd experience on Earth, completely non-toxic, completely safe to handle. And this again reduces costs in the vehicle.
Sure.
You suddenly don't have to have as much regulation on transporting this thing. You don't have to spend as much on ensuring the entire team is safe, because the system is completely safe as it is. And it's getting down, chipping away at all of those costs. But because the vehicle is so safe and simple, it means less failure points, which means lower risk of delay. But it also means you have far more agility with how you move the vehicle. You can move the vehicle to different parts of the world at a much shorter timeline if you need to. So, we want to be able to provide a system that can, it's less relevant in the UK, but definitely in the global market. If you're in a country such as the USA, be able to launch from anywhere in the US and a very short timeline. We usually tell us where to be launching from, and we can move the vehicle there because it can sit there and be ready. And this is supported, again, this is how we start to see how our software tunes into this. This is supported very much by optimization technology. Because as I've mentioned, the market may change. Things change constantly, and it's never going to stay constant.
Well, I was going to say, particularly in your market, which is always changing, I imagine it's always future looking as well.
It's plateauing out, but I think it'll be very unwise of us to assume in 4 or 5 years the market will not have changed at all, or won't be in the process of changing. And so again, with our engine design, one of the key things for me when we're designing it is, yes, it's got to have fairly high performance, and it's got to be very low cost. But what's very important to me is that you can iterate the design quickly. And this is where you can the advantage of having a very simple design mechanically that also can benefit immensely from a clever tool such as more AI, being able to start to automate redesigns of a system. So if we need to scale something up on our system, we can run it through that, and it's a far shorter process. Yes, it's not simple as just changing something and launching again, but it's a far simpler process changing our vehicle's performance with the engine architecture and design we've gone with, which means we can pivot if we need to. We may get, in a few years and realize, oh no, this market the payloads have gone up slightly. It's not a disaster for us. We go, okay, we can scale this up slightly, all the way up to a few years before launch.
Yeah.
And it's enabled because we have very clever technology can automate so many designs of parts of our systems and give us safe, stable results very quickly that let us start pursuing. So we save weeks and weeks and weeks of engineers' time every single time we use more AI.
So it's safety, it's efficiencies, it's absolutely.
Yeah.
So kind of just looking at for certainly for me as a layperson, whenever we're doing these and I'm talking to very clever people such as yourself, I always try and bring it back to kind of layman's terms. And for those kind of uninitiated, kind of what does the UK space sector look like at the moment, and how are you engaging with that, and kind of what does that mean for SmallSpark, and I guess ultimately then for our investors and the opportunities that are there in the sector?
Yeah. So the UK space sector is going through an immense change right now, and it's a really exciting place to be. As I mentioned, we do a lot of work in data collection, in satellite manufacturing. The UK is one of the world leaders in that. And in sensor technology, UK is arguably the best in the world. We have things like the Satellite Applications Catapult working on bleeding edge research in terms of sensor technology, and it's a wonderful place to be for that. But as I say, they are pushing towards being able to launch now, and spaceports now slowly starting to come online. It's not just launch to orbit; it's also suborbital launching. So this is why SmallSpark is developing 2 launch vehicles over the next 5 years. We're developing Frost Micro, which we are aiming to have online either late this year or early next year, depending on how a few things work out with the spaceport. And that'll be a suborbital launch vehicle. So that's going to be a very, very cheap vehicle to fly. We're talking sub £100,000, this vehicle. Right. And it'll be able to take up to 50 kilos to space for up to 200 seconds, then bring it back down again. And what this enables companies to be able to do is, especially for small companies, it enables them to do validation of technology in microgravity in space-like environments for short periods of time, for multiple orders of magnitudes reduction in cost. It allows pharmaceutical companies to start doing microgravity research for various drugs. This is a market that is exploding right now. It's why the UK Space Agency has actually recently started commissioning studies into these kinds of markets, because we're talking with launch brokers and we're finding out these markets of sending stuff to space very briefly is growing immensely, especially in pharma, in research, groups in astrophysics research groups. I think it's a passion of mine. this very low cost ability is something the UK has not got and has never had. And it's something we're going to deliver to the UK within the next 12 months. And the spaceports will be there in Scotland and in Wales to allow us to do that.
Which has a knock-on effect into all these other industries then as well.
Well, this is the thing. It helps us because firstly, it's a nice revenue generator, but it has multiple effects for us. It lets us validate a lot of our technologies because we are using a common architecture between our vehicles. It'll be almost an identical engine that powers both our vehicles. So it allows us to gain heritage on our flight engines while generating revenue. And more importantly, it allows us to actually stimulate a lot of these early stage startups that couldn't have existed before, because the barrier to entry to validating space tech was so high before. You would have to spend millions to actually just test it in space. But we're now providing to the UK a much lower barrier of entry where you only have to raise a few $100,000 really to actually start validating your tech in microgravity and in near vacuum environments. So we start to actually hopefully drive our own customer base up for the future by enabling them to actually get an easier start. So we want to really drive this growth. There's already a ton of space companies here, but we want it to be more. Because if the UK wants to be a world leader, we want to have as many startups in the space industry as possible. You look at the US, there's thousands of them. And the UK really needs to drive towards that. And that's where the government's pushing it. And it's why we've created Frost Micro, because we want to enable that as well.
Great. So you've got Frost Micro, which is suborbital, and then you've got then
Frost One.
Yep.
Frost One, is an orbital launch vehicle. We're aiming for that for late 2025, early 2026.
Fantastic.
And so it's built off a common architecture from Frost Micro. So Frost Micro tells us an awful lot about the system performance. So I think I would tell investors not to be too worried if they see the design of Frost Micro for Frost One iterate for a bit over the next few years. We have the initial.
That's a fairly standard process for any kind of innovation. Absolutely.
Exactly, it happens. We are pretty confident on the performance level of the vehicle, and we'll know more, and we'll just adjust the design based on what we learn from Frost Micro. From our tests of our prototype engines, they're performing beautifully. They're performing really, really well. Very, very happy. We're now starting to look into actually building our own dedicated test site rather than working with partners because we want to get our testing cadence up. But no, so Frost One is very much catering for the much larger market that the UK is going for. This is a market that's expected to be worth billions and billions over the next few years. And it's the launching of small satellites. We make so many of them here. Last numbers I checked, we're making, maybe 30, 40% of the world's small satellites, or these components for them within the UK. That's an immense market just in our back door. And again, if you can launch in a company you're manufacturing your system in, it's again reducing your cost. So it's again it's just leaning out the entire system. And that's what we're trying to do with all of our vehicle lines, take everything off that you don't need. I think we use the analogy, if you don't really care what car or vehicle your post is delivered in, you care it gets to you at a low cost, and a stamp doesn't cost you £500.
It's efficiency, it's cost.
It's all you get, exactly. It's cost efficiency. That's the thing. That's the most important thing for this market. It's not about perfecting having style or it looking really nice. It will look nice. Our vehicles will look great. Don't worry, they're not going to look ugly. But it's this market. What customers care about is just cost efficiency, and it's not just cost efficiency of the vehicle. It's taking a sort of holistic approach of everything that a customer has as a pain point and removing all of that. And that's what we're trying to do with both our optimization technologies by allowing both ourselves and our customers to get designs done quicker. It's what we're doing with Frost Micro by enabling a far lower barrier to entry to actually getting in and getting your first funding round done to be able to actually start testing space tech and actually get into orbit. So when you need to launch, we're able to launch quickly and reliably because we've got a safer system that on standby and ready. And we're seeing already a huge interest in this from defense companies around the UK. It's not about making missiles. I think it's important to really state that. We say defense companies, SmallSpark does not make missiles. But in the future, what the real interest for defense companies is data. And that's what SmallSpark can enable companies to provide. You can be ultra responsive. If you need to get a satellite up in a few days, SmallSpark will be the company you go to do that. And that's where the immense interest is being seen in our architecture, because it's radically different from anything that's on the market right now.
So kind of talking about that then, I guess what have been your particular highlights since launching SmallSpark and validation for what you're doing, etc.?
So I mean, the first highlight I think was when we won Graduate Starter of the Year for Wales. That was a really nice one. It seems so small now, but this was a few years ago. It was probably after a very tough year in the company. The first year was very tough. We were totally broke, had almost nothing. We were all very stressed. We won Graduate Starter of the Year, and then a few months ago, I was also awarded Young Entrepreneur of the Year at the Great British Entrepreneur Awards. So sort of selfishly, that was a really nice thing to see. I mean, the highlights of me initially was all the support from academia we were seeing and from Research England. You know, we were the first company to get awarded 2 rounds of funding from Research England's biggest space fund called Sprint. So we were the first to get 2 rounds, and we're actually the only ones we awarded 3 rounds of funding for this. So we work, and it demonstrates how cutting edge the stuff we work on is. And not only do we do these cutting edge projects, we actually do follow through and demonstrate the outputs. You know, one of our projects was building our test engine. We built it, and we fired it, and been continuing firing it. The other projects were building more AI, or what would become more AI. Again, we're seeing incredible progress with that. And now we're building on a new project, a vehicle with an engine we call the S4 Newt, which is an experimental satellite thruster. I won't touch on it too much now because it's incredibly experimental. I'm going to talk about things once they start showing results.
Absolutely.
Again, it's showing immense promise, and we think it'll probably be an absolute win for the industry if we can get this thing to work. But that's been huge for us, is seeing the results. And obviously, the testing of our Hive engine, the engine we call the S4 Hive, was incredible. You know, I'll be open. It was the first rocket engine that I had actually designed and built. I'd designed them in the past. I'd done all the theory. You know, I'd done through the training, but to actually design it, build it, and for it to work exactly how we expected it to on the very first time was phenomenal. I think that might be the proudest moment I've had in my life.
Well, I was going to say all those kind of original comments from from lecturers and mentors, etc., saying you're mad, etc.
Exactly.
I guess that's kind of the moment where you go, do you know what?
I think a bit of madness is good. That's the thing. It's about the right levels of madness. But no, I think the huge thing was the validation of just suddenly going from this company that says we're going to build rockets to actually being a propulsion company that is building and testing rockets that actually do work. I think that was always the exciting thing. It was always the nerves. If we fire this thing and something goes wrong, it's going to be another 6 months of back to the drawing board trying to work out that suddenly, you know, tens of thousands of pounds down the drain. But that was the highlight, was actually seeing this thing fire. And, you know, we're now going from strength to strength in the new year. You know, we're now developing lighter and lighter weight variants of this engine. Now that we are very confident in how we understand how it works. You know, we're starting to get to sort of used to little quirks with it, you know, and starting to really optimize it. And then beyond that, we're really scaling up the size of this thing. So we're going to make a version of the engine we've been testing for the last year, about 8 times scale. And we're testing it at the same site, hopefully towards the middle to the end of this year. And that will be the prototype for the engine that will actually power our launch vehicles.
And do you do the testing and launches in Wales itself?
No. So right now we test at the Westcott Venture Park, sort of near Oxford. But what we are doing is we are finding that it's a fantastic site, a brilliant company we test with, airborne engineering. All the expertise in the world could not sing their praises enough. But we are now looking to build a facility in Wales ourselves. When you do the maths, it's actually not. You don't need a ton of investment to build a test site. A lot of it is just making sure you have lots of heavy bits of equipment to protect around an engine. So we're going to be building, you know, it's going to look rough. It won't be the prettiest looking test site in the world, but it'll let us
if it does the job, that's the main thing.
It'll let us test very large engines very, very safely, and it will be within Wales. So this is part of what we're doing. You know, we're pushing forward our Series A round actually now to just more aggressively pursue this. Now that we're seeing the amount of interest we're seeing commercially from very large players in the industry, it's given us a lot of confidence in what we're doing. We've almost thought, you know what, no, we're going to start really accelerating our timelines here. We've been overwhelmed with the positivity of the industry and what we're doing and the excitement. And so we've learned to try and be a bit more bullish on ourselves now and really start pushing forward to what we're doing.
Absolutely, I think, you know, that's become evident in kind of the updates that we get from you, etc., about kind of the commercial traction and interest is phenomenal. So usually I kind of wrap up talking about the company, etc., by asking for your hopes and objectives the next kind of 12 months, 3 years, etc. But you've kind of summarised some of those, you know, with the launches and things like that, and the growth of what you're doing. But kind of anything else that you're particularly looking forward to over the coming months and years?
Yeah, no, I think the ones that I'm very excited about are the things that I've alluded to in this call with relating to engagement with defence companies that I can't quite talk about publicly yet. But we're very much hoping in the next 6 to 12 months to make some, I mean, what I would define as huge announcements that I think are going to really catch our competitors off guard. I think that's what I'm very excited about. There are really 2 other launch competitors in the UK. And I think some of the things we've got cooking now could catapult them. You know, they're 3-4 years ahead of us right now, but we could close that gap unexpectedly quickly, based on the progress we're seeing right now with a few of our partners. That's something to be very excited about. Just from a competitive point of view, it's going to be very exciting to start going toe to toe with some of these companies that I idolized and actually I applied to when I was younger. To start going toe to toe with them has been very, very exciting.
If you can't join them, beat them. That's the
yeah. Well, I say, you know, in the nicest way, SmallSpark is a good bit. What we do is powered by spite. You know, we're a very friendly company, but all of us have had a sort of got a bone to pick with someone in the industry, and so it will drive us to make sure this thing does work.
As you alluded to, you were told not to do it, so that gave you that kind of drive to go and do it.
I think it's the only reason we managed to survive those first 3 years. Was because we started it and I was almost too embarrassed to stop now, because I told everyone I was doing it, and I was like, well, if I stop now, they're completely right. So I think we were going to all willing to almost die before we didn't let this work. I think we've demonstrated, definitely we've got grit. But so it's those announcements we're very excited for. But I mean, obviously the flight of Frost Micro is going to be absolutely incredible. We are so excited for flying that late this year or early next year. We're hoping to be the first fully commercial suborbital launch vehicle in the UK. I can't promise we're going to do that. There are a few other people coming online now that are trying to do it, but we are pushing to be the first. And regardless of if we're not the first, we're going to be the cheapest. We have a very high degree of confidence about being the cheapest, and we are using our connections in academia to start to really position ourselves as the company that researchers go to and to get this low-cost data. You know, we're already working with the UK Space Agency to start to see how the UK can position itself for when Frost Micro does come online. You know, we want to make sure there's government support for academics to start doing microgravity launches and these kinds of things. But it's nice to see the response from the UK Space Agency, because you can see they're excited that we are bringing a capability to the UK that it's not had and that it wants to have. And it's a capability they used to have decades ago, and we gave it up. Tragically, we gave it up. And I think they're very excited to see it come back.
So it's another way for the UK to put itself kind of back on the map then, I guess.
It really is. And the thing is, it's important to us what's different about us from all the other pretty much all the other space companies in the UK. You know, apart from a few, is that we are actually doing what we say we were going to do. You know, there's rocket companies are a dime a dozen around the world, but none of them actually have rockets. They've got paper. We actually do the hardware. We test the hardware. We blow up the hardware sometimes, but then we build a better one that works better. You know, we are not afraid of failure, you know, but we push things to their limit. You know, we've had things go wrong with our engine. I'm not going to pretend nothing's ever gone wrong with it, but the engine's still absolutely fine. It works brilliantly, and we solve those problems, and no problem has ever occurred twice with our engine. So that's where we try to differentiate ourselves a lot. I think it's why we start to see the traction we have since we started our testing. Is companies are starting to realize, oh, they're actually doing it. They are actually building these systems. They're getting we've got an engineer that was incredibly cheap to build, and it's performing just as well as engines that cost 7-8 times the amount, but it was a fraction of the cost and a fraction as simple.
Well, look from our perspective, I mean, we obviously first got involved with yourselves through the SEIS initial funding, and and everything you've kind of said you were going to do, you've been able to show that you've done it, etc. Which is why that's such a valuable resource for us, kind of when we're looking at EIS funding, because we know you guys tend to deliver.
We hit
what
our targets.
Absolutely.
I mean, I think I appreciate the faith that you guys took with us early on. You know, we had a lot of backing us, but we were claiming we were going to do a lot of crazy things. And I was thrilled we managed to convince you with the SEIS funding, because that's what really got us over that line of really starting these commercial engagements. You know, with these defence companies. I think that I'm hoping that in a few years, Deepbridge is going to look back at that £100,000 they put in and possibly see some of the best ROI they've ever put in on a company. I think. I mean, I'm sure every company says that, but I truly believe it will see some of the best return on investment you'll ever see for a company.
Good, excellent. Well, look, we're all very excited. I think it's we as a tech investor, we see all sorts of different tech, but there's probably very little that's quite as kind of exciting as kind of space tech, etc. So exactly. So we may pigeon you as kind of like our mad scientist, but if you don't mind that crowd,
I don't mind. No, I'll give my hair a few more weeks to grow out, and I can sit with you. It's absolutely fine. And I feel like it inside anyway at this point. But no, we've loved working with Deepbridge. And the support we get from you guys is fantastic. You know, I'm constantly bugging Adrian about just questions I've got, and he's so good at helping. Good. You know, it's been great working with you guys, and I hope that continues for the future.
Yeah, absolutely. No, we're delighted to be on board. So that's great. Yeah. So kind of, I'm conscious of time and your time, etc. So kind of just away from SmallSpark, I guess, you know, that probably takes up a vast majority of your time and of your life. But kind of away from that, what are your personal interests? How do you kind of wind down if you need to?
Yeah, no. So it's actually what we discussed beforehand. So I enjoy doing a lot of sports, but I don't enjoy watching them. So generally, I'll tell people. So I very much enjoy boxing. So I do a fair bit of boxing. I used to do a bit of white collar boxing. The pandemic kind of put a stop to any actual events. But no, I enjoy boxing and weightlifting in my spare time. You know, I enjoy cycling. It's a lot of that kind of stuff. I used to play a fair bit of rugby when I was younger. Yep. It's those kind of things, especially with what we're doing in SmallSpark. We try to really push about making sure you do take time off and do care for yourself. Because I think actually, the toughest time I think for almost our entire company was the period when the gyms were shut down. Because suddenly we were working all day and we had no real outlets. And so a lot of the time it's finding outlets. But academically, I have a real interest in astrophysics and astronomy. So that's what my degree was in, was astrophysics, astronomy. You know, it's a huge passion of mine. You know, I've got a big telescope. You know, it's one of the ways I to sort of relax, especially in Wales. If you can get a clear sky here, the views are absolutely phenomenal if you go up into the valleys. Absolutely. So that's really interesting of mine, and that's kind of bled through to into SmallSpark with us trying to sort of do what we can to support academics.
Yeah, and I think you're absolutely spot on about making sure that people do take time away from work just to refresh, recharge, because you know you don't.
That's the thing. Working in a startup's tough. It really is. Like you have to have the passion for it, but we try not to take the mick with people. Like the people who work at SmallSpark, they do put their soul into this, and so I'm very wary of making sure people don't burn out. You know, we try to really give people time off when they need it, and these kinds of things, support however we can. You know, company trips to the cinema, that kind of stuff, just to keep, you know, make sure people realize we appreciate the work they put in, because every member of our team has more than earned their keep at this point.
Superb. And then my closing question to all of our guests on our podcast is, so our guys can get a bit of a kind of an insight into who you are, etc. I mean, can you tell us what your kind of favorite book or your film, kind of what music are you into? Just kind of
okay. Oh, that's a tough one. Okay, so
your favorite book then?
Favorite book. Okay. I've moved to audiobooks a lot recently.
They count. That's fine.
Yeah. So I'm currently reading The Stand by Stephen King. I'm really enjoying that. That's a really, I wasn't aware it was about a pandemic when I started reading it. So I started reading it, I sort of got people coughing in it. I'm like, but my favorite book, it kind of does show probably that I am a bit of a space dork. My favorite book is Cosmos by Carl Sagan. Absolutely my favorite book of all time. Same as my favorite TV series of all time. Is the Cosmos documentary series from the 70s. It was old even when I was born. But it's an absolutely phenomenal series. I think anyone who's looking to get into space, if you can look past kind of the old-timey graphics, probably the best science educator of all time in my view. So the Cosmos TV series and book
when I was at university, Joe, one of my flatmates, who's a good friend of mine, was an astrophysicist, and Cosmos was always on his desk.
I think Carl Sagan's responsible for a lot of the people in the space industry now. I think a huge chunk will say that Carl Sagan was the guy who inspired them. So I think Cosmos definitely my favorite book, almost no contest.
Very good. And then I guess just kind of one, what's your go-to film? You know, when you're wanting to unwind.
The Good, the Bad, and the Ugly.
Excellent.
Every time. It's my dad's favorite as well. I think I've got good memories of when I was a lot younger. Even now when I see my dad, we still watch it. But I used to watch that thing on video so many times when I was younger. Absolutely favorite film. Then maybe Terminator 2. Terminator 2 is probably my second favorite film.
Fair enough. Very good. Excellent. Yeah. Well, Joe, thank you very much for your time. That's been fascinating, just to get a real insight into kind of where SmallSpark's come from, what you're doing. We're very excited about what you guys are doing, and we look forward to working with you as we go forward. And
absolutely.
So thank you very much.
Thank you so much for having me. That was a really, really good chat. I always enjoy talking about what we do. So I like showing off.
And that passion comes across. So thank you very much. Cheers, Joe.
Thank you very much. Okay, brilliant.
This podcast was brought to you by Deepbridge Capital LLP. Deepbridge is authorised and regulated by the Financial Conduct Authority. Please note that investments discussed are both illiquid and high risk and won't be suitable for all investors and should be considered as part of a diversified portfolio. The content of this podcast should not be construed as financial or taxation advice. We recommend investors seek appropriate professional financial advice. Any views expressed may no longer be current and may have already been acted upon.